Okay. Today, inshallah, we'll just take the model exam paper, as next week we'll have the exams. Okay. Can see on the LMS, the BCC has given us the exam structure and some previous exam paper. Okay. The topics covered were part 1 to part 10. And more importantly, here is from part 8 to 10, which talks about SQL, normalization. And apart from that, it's about Python programming using data structures. Fine. So this is what is given by the BCC. Okay, 2 parts in final MTA exam, which is MCQ and problem solving. Fine. Okay. Now, before we take this previous MTA exam and discuss this, if you have any questions that you want to ask with regards to part 1 to 10 or the midterm exam, please go ahead if you have any questions. Yeah. Okay, fine. So, can you hear me or not? Can you hear me or not? Great. Thank you very much. So as you can see on the screen, this is one of the previous exam of like 2019. Okay. And 2 parts it has. Part 1, it's multiple choice MCQ, and it is just for 5 marks. Okay, out of 30. And part 2 is about 55 marks, which is problem solving. Fine. So this 5 is out of 60, and out of 30 it is 2.5. And here it is rest 27.5 marks out of 30. So if you do problem solving, okay, you're sure that you will have the marks above 25 plus. Okay. What about these multiple choice questions? Basically, these questions comes up from all the parts. Okay, from part 1 to part 10. So you can see some questions analysis, some questions data gathering, some questions about preparation, some questions about the relational data. As you can see, this question is on primary key. Fine. This question is on view, which is also in relational data. Fine. This question is about normalization. Fine. Primary key attribute, composite primary key in second normal form. So these, you can see that almost like every part carries the will be considered in this part 1. Part 1 to part 10, almost every part except part 7 is considered in this part 1, which is just for 5 marks out of 60, which is like 2.5 out of 30 marks. Okay, simple and easy. Do you want the recording of this session? I did not record it. Okay, so that is part 1, which is for 5 marks out of 60, will be like 2.5 out of 30. Okay, so as I said, like this takes from every part of the, the material, every part of the material. Okay, so even you can see that these questions where from they are arising. Fine, every part 1, part 2, right? So this is like from part, I think part 3. Fine. Similarly, you have questions from 7 to 10. It's all from part 8 to 10. Okay, talking about the primary key, composite keys, foreign key, talking about the views, talking about normalization, talking about normal forms. Okay, that is normalization. So you can expect like in part 1 just for like 5 marks out of 60 and 2.5 out of 30. You can expect like from any part these multiple choice questions, right? But most importantly, part 2, which is 55 marks, which is like 27.5 marks out of 30. 27.5 out of 30, which is almost like 90% of your midterm exam. So if you can do this part, solve this part, you are like almost 90%. You have the marks. Okay, which is almost like 27 and a half marks. Fine. So what does it compose of? Part 2. I discussed this before, like I said before in the previous session, I think in the last week during the lab session, that you should be aware of Python programming, especially the data structures like list, tuples, dictionary, fine, and normalization process and SQL. These are important in problem solving. Okay, these are important in problem solving. Some of the analysis may also be important, so do not ignore to study the analysis part also. Data analysis and data preparation, what we took in like part 4 to 6, I think, is also considered as important. Fine. So if you look at this paper, what will be the output of the following Python code? Give the or write down the exact output. Exact output in this, you have to write like if it is going in the next line, if it is printing in the same line, that you have to write that in exact form, right? Even if you miss, for example, here we have a print x and here we have print x plus c. So this should be printed in one line and next line this should be printed. If a student write in the same line, this may deduct some marks. Okay, so you have to be aware of this. And you see here, for example, this question is using list. Okay, is also on lists. Then this question is also on the list. This is on tuple, fine. This is on set, and this is on dictionary. Right? All the 4 data structures have been used here. All the 4 data structure has been used here. Fine. And which notebook has this? Which notebook has this? I did show you in the last meeting. Notebook 1, right? I hope that everyone has gone through the notebook 1. The basic Python data structures. I hope that everyone has studied this part from the notebook, at least from the notebook. Okay, if you go to other resources, this is well and very good. Okay, but not at least from the notebook. You have to study these data structures. Okay. So if you look at the notebook, you have a clear idea about what you have to study in this notebook. One, we have this Python basic data structures. Here we talk about list, tuples, set, dictionaries. Okay. List, order list of elements of any type, any length. So list can contain any type of elements. Okay. List can contain any type of elements. Tuples order elements of fixed length with a particular array, that is a number of elements, that is fixed number of elements. Okay. Yes, even dictionary will have the same, but dictionary is different from the list in a way that dictionary has key and value pair. Okay, it can store any type of values, but it has key value pair. Okay, so then set contains only new. Yes, yeah. List can take dictionary. List can take any type of element, objects, any object it can take. List can take another list inside it. Okay. Then it has sets, then it has dictionaries. So go through this, do some activities with the sets, explore more on other resources. Okay. Explore more on other resources. Fine. So you have the list here, for example, you can select the list with different elements. So I can add a list here, for example. I can add another list inside this. 1, 2, 3. There is another list inside the list. Fine. So in this list, you can see that what is X here is you have a text here. Fine. And I can access that elements. Even I can access that elements. Like I can access here the list element by their index. Fine. That okay, this has index 0, 1, 2, 3, 4. So this has X of 4. Right? So X of 4 is what? Me X of 4 is 1, 2, 3. So X of 4 of 0. It should give me the first element in the X of 4 list, which is 1. Okay. Similarly, X of 4 of 2, for example, it should be 3. So this should give me 3. Fine. So this way you can, trace through the list and try use these lists. It also has a function, for example, it has a length function, it has other functions like sort, reverse, okay, append, fine. So other functions. So you can see similarly here also some functions are being used in this question. Like first of all, x is equal to a. So x has an element a in the list. So how you identify the list? With a square bracket. Given the square brackets, it is a list. Print x, it should print like in a square brackets. Should print in a square bracket the element. It's same like this, it should print on the screen. Fine. Let me share this. Yeah. So print, it should print like this in the same fashion. Fine. Now here, plus, what does the plus do here with the list is that it will add two lists. So we have A plus C. It will print A plus C, which is AC. So you should print a list of AC. Now length of the list. So what will be the length here? Any idea what will be the length here? Zero. Why zero? Because it is empty list. What is given inside the length is an empty list. Okay, so that's why it is zero. That's why it is zero. Fine. So you have to be very careful, like while reading this code and trying to find its output. X dot append C will add C to the list X. Finally print X. What does this will do? Print X. What it will print? What does the last print X will print? Will it just print A, or will print nothing, or will print AC? Why it will print nothing? It prints AC inside the square bracket. No, not append. I'm asking about print. The last print. Not ACC. It will just print AC. AC as a list. You should print AC as a list. It should not be like uh, should not be like, what do you say, just AC. It should be more like as Isra typed here, AC in the form of list. It should be like this. Okay, so you have to be very careful while printing the list. Print it exactly as a list. Don't print it like just the numbers, just the letters, or just the elements. Fine. Again, we have this question is also on the list. Is also on the list. It says X is a list of 1, 2. Y is equal to X. That makes what? Y also a list. Y is equal to X makes Y also a list. Print Y, it will print the list 1, 2. Okay. X dot append 3. Append means what? Add 3 to the list at the end. So it is 1, 2, 3. Print Y. Now it prints what? 1, 2 or 1, 2, 3. 1, 2, 3. Ahmed Same says 1, 2, 3. Why it prints 1, 2, 3? Why not it prints 1, 2? Because we are appending to X, not to Y, and I'm printing Y here. One, two, or 1, 2, 3. 1, 2, 3. Call by reference. MashaAllah, you call it by reference. These are referenced objects. Very good. As Ahmed said, it is referenced objects. Fine. Once you refer it, it has a reference to the same list. It says Y is equal to X. It has a reference. Both X and Y has the reference to the same list. Any change you make to the X will also made for the Y. Any change you made for Y will also be made for the X. So the list will be 1, 2, 3. Okay, that's good. And then Y is equal to list of X. Y is equal to list of x. Okay, so here it's like a copy. Now we are changing y to make a separate copy, y as a separate copy. Then x dot append 4. Then we say print y and print x. So what is print y now? What it will print? Because we are saying x dot append 4 here. So adding 4 to the x list and printing y. It should print what? 1, 2, 3 and not 1, 2, 3, 4. Why? Because of this statement. Okay, this statement made y as a separate list having the contents of x. Okay, yes, and finally print x. X will have 1, 2, 3, 4. X will have 1, 2, 3, 4. Now with this, I'm sure that you got a clear idea about the list. Okay, one simple question here it is given: x is equal to 1, 2, 3, 4, 5, 6. X of 2 plus 7, how much? X of 2 plus 7, 10. Very good. Yes, 10. Because x of 2 is 3, 3 plus 7. Okay, x of minus 1, minus 1. How much? X of minus 1, minus 1. 5. Okay, what is x of minus 1? What is x of minus 1? 6. Because the negative index starts from the back. Okay, if I say in this one, x of minus 1, minus 2, minus 3. If I say x of minus 10, what will be the value? X of minus 10. X of minus 10 is error because there are no 10 elements. Type x of 0 is which element? X of 0. First element in the list. X of 0 is first element in the list. Now we write only 6 here. We don't write the list here. In this question answer, in this answer, we are printing the element. When we are printing the element, we just write the element. Don't write the list. While you are printing the list, you print the list. Okay, please note this. For example, I'll do this in here. Say y is equal to 1, 2, 3, 4. Okay, while say print y, this is different. It will print 1, 2, 3, 4. You see, this is print y. Okay, let me put a message for you. I'm printing y. So it is 1, 2, 3, 4. Now, if I say list of minus 1, y of minus 1, it will print me the last element only. It will not print the list. So while you are printing the elements, you print only the last element and don't print the list. But while you are printing the complete list, then it will print the complete list as you can see here. Okay. Otherwise, it will just print what? The element as it is. Fine. Hala, is it clear to you? Hala al-Masri. Okay, great. Fine. So you got an idea about Python programming, its data structure. So mainly this question is for 25 marks out of 55. It's all about list tuples. Here you have a question on tuple. Here you have question on sets. You have question on the dictionaries. Fine. Go through it and also look at some other resources. Fine. To study on this, to more on this part. Okay. Fine. Now question 2 is about normalization. Question 2 is about normalization. In the normalization, they'll give you any relation. Any relation, it means any table, fine, along with their dependencies and the primary keys. Dictionaries will have the same key and names. The keys should be different, but they can have the same values. Dictionary keys can be the same, but well, what is a dictionary? Let me just register. Look. Think key should be unique. Name can be the same. I mean, the value can be the same. Should get you the first element. If they have the same, should get you what? The first element in the dictionary. Okay. If they have the same, it should get you the first existence of that key value pair. No, there is no override here. See, if you have that course code, for example, if you look at this notebook, we have course code TM351. So if I add another course code, fine, and we try to print the dictionary value, fine. So it's overriding, fine. The new one will be considered. It's overriding. There is an override, meaning that it should override if they have the same. It's overriding. Yeah, it has only one item with the same key and the value. So I think it's meaning that it should be unique. Meaning that it should be unique. Okay. Yeah, that's good. Thank you very much for bringing in here. And that's why go through these all data structures, how they work, their functions, fine. So this you may expect in the exam, fine. It takes good marks here. 25 out of 55 marks. So even here, I think it has a dictionaries. So look at question number 6 here. What do you have as a dictionary? You have ID and name. Dictionary of ID will print you the ID value 0, 1, 2, 3, right? Dictionary of department is equal to computer science, right? So now you are adding department as another element here in the dictionary. If you print the dictionary, it should print what? It should print the dictionary. But here is a comment, okay? Here you have a print, it's just a blank print, so it should go to the next line. Now print keys are for key in dictionary, print key. Now this is one way you trace this key. So if you say key of that particular value, okay, or index, it should print that. Fine. Okay, key in dictionary, it's values now. Here you are printing the values. So here it will print ID, name, department in this for loop. And in this for loop, it should print 0, 1, 2, 3, John Doe, and computer science. Okay, here. Okay. Fine. Now moving to normalization. Normalization, you all know the normalization process is about normalizing the tables so that we can avoid some anomalies, repetition of data, and anomalies such as insert anomaly, delete anomaly, or update anomaly. Okay, so in normalization problem, basically what we get is a relation and along with the primary keys, or also sometimes they say candidate keys. Right? Candidate keys are those keys out of which one can be selected as a primary key. Right? So here in this relation, the question itself given that patient ID, doctor ID, date, and patient is a primary key. And the patient ID determines patient name. This is dependency. Doctor ID determines doctor name. It's also a dependency. Hospital ID determines hospital name. This is also a dependency. Okay. And you can see that the patient ID, doctor ID, date as a primary key, and even it is underlined here. Whatever is underlined is a primary key. Now the questions are listed here. That can a student have more than one appointment with the same doctor on the same day? Justify your answer. So how do you find this? That a doctor can have, sorry, can a patient have, this is not a student, this should be patient, okay? Can a patient have more than one appointment with the same doctor on the same day? Okay, so we need to record, let's say that in this relation, in this table, 2 records of the same patient with the same doctor on the same day. Is it possible? Did you understand this question? It is not possible. No. Okay. So how do you find that it is not possible? Justify your answer. Justification is required here because it says justify. Because primary key must be unique. And what is there in the primary key? It says the primary key is patient ID, doctor ID, and the date. and the date. So patient ID, doctor ID with the date should be unique. On the same day, it means it is unique. What if I say the primary key is just patient ID, doctor ID, and the hospital ID, for example? So at this point, if I'm changing a little bit here, that I'm removing date, okay, from the primary key. I keep the primary key as doctor ID and patient ID. Now, can can a patient have more than one appointment on the same day with the same doctor? It can have. Okay, so it can have because the date is not primary key now, right? So you have to read the scenario, understand it, and then answer with justification that big why it cannot have, because the date is a primary key, part of the primary key, and cannot be duplicated on the same records. Fine. So that's why it cannot have. So the answer for the first part is no, right? Along with the justification that saying that it cannot have because of the primary key. Okay. No, doctor, I did not get you. What do you mean? Still, patient ID and doctor ID are not unique. Yes, it can have the different. So if we remove that, for example, any one of these IDs, we change with different doctor on the same day. It can be possible, right? Patient ID with different doctor on the same day is possible. If it to be same patient with the same day, same doctor on the same day, should not have those as a primary key. So it will be repeated. Okay. Now, second part of this question is what is the highest normal form this relation conforms to? Meaning that this relation, in which normal form it is in, the highest one. It is in first normal form because there is no duplication of data and there is a primary key. There is one identified primary key and there is no duplicate data. All the attributes are atomic or single value. Okay. But not into NF because what? Because of what? But not into NF. So why it is not into NF? There is a partial dependency. Where is a partial dependency? Just give me one partial dependency. Patient ID determines patient name. Similarly, doctor ID determines doctor name. Yes. So there is a partial dependency, right? So if it is asked you what is the definition or when we say that the relation is in second normal form, then what will be your answer? You should say that it should be in first normal form and there should be no partial dependency. Okay. No non-primary key depends on part of the primary key. Part of the primary key. So this is clear. Third question is normalize to next higher relation form, showing the new relations in a manner that appointment is shown here. Make sure you identify the primary key for each normalized relation by underlining it. 12 marks. So now, how many relations you will get out of this? Every dependency, you have to make it as one separate relation. It means one separate table. And you name them. How many relations you can get from this appointment relation now, depending on the dependencies? We can get 3 more. What are those 3 more relations we can get? No, 2 relations. We have 3 dependencies here. Apart from the appointment, we have 3 dependencies. Dependencies, you read the dependencies here. Patient ID determines patient name. This is one dependency. Doctor ID determines doctor name. Another dependency. Hospital ID determines hospital name. Third dependency. But here, hospital ID and hospital name you can still keep in the appointments because none of these hospital ID is not a part of the primary key. So that it should conform to the next higher form, that is second normal form. Fine. So now it is 2 plus 1, as Ahmed said, is because of hospital ID is not part of the primary key. So it is 2 plus 1, 3. Okay. But if you normalize to third normal form, then it becomes 4. Okay. If it's asked about normal form, then it goes here. Right. Okay. So now here what we have is that we have appointment, patient and doctor. But if it goes to the next 3NF, we should have another one which is hospital ID. Okay. Now while I am writing appointment, okay, in 2NF, what will be the my appointment table in 2NF or appointment relation? What are the attributes inside the appointments now? I should have what appointments as patient ID, doctor ID, date, because these are the primary keys, along with hospital ID, hospital name. Without patient name and doctor name. Great. And what the new relations? I should have patients and doctor. What will the patient relation? Patient ID, patient name, and doctor relation is doctor ID, doctor name. Great. Fine. I'll write that here. So the new table patient will be having the patient ID and patient name as one relation. Okay. And doctor as doctor ID and doctor. Fine. Now removing this doctor name and patient name, keep the the new appointment. Okay, appointment table. That's okay if you can change it. Don't want to change, keep it as it is, no problem. It will have patient ID, doctor ID, and date. Okay. Along with that, it should have the hospital name, hospital ID, hospital name, and time. Okay. All those three should have that patient ID and doctor ID and date. It's primary key. Along with that, it will have hospital ID, hospital name, and time. This will be the new appointment relation along with doctor and patient relation. Fine. Is it clear? Similar type of questions you can easily solve. Similar type of questions you can easily solve. Try some examples. You can easily do that. Fine. You can write your own examples. Like for example, make a relation of course registration, tutor course, tutor student course registration, where you add student data, tutor data, and course data. A student register in a course given by the particular tutor, right? And then you make your own, candidate keys, primary key, and then normalize to first normal form, second normal form, third normal form, just like a practice, right? Okay. Third question is about SQL. Third question is all about SQL. Now, in this question, you see that relations are given like movies. It has movie ID, primary key, title, year, ratings. Okay. All rating, top ratings, audience rating, movie lens, user rating, which is average rating. So it is given here, right? Now, we also have here movie actor, movie ID, actor name, ranking, and movie country ID and its country. These are three relations given, or three tables you can say given here. Okay. Here is the questions. For all movies released in either 2005 or 2006, list title, year of release. What I want here is the title and the year of release for the year 2005 or 2006. So first find where I can find this data, in which relation. Try to find in which relation I can get this data, that is title, year of release, where the year is 2005 to 2006. So look at the first table, movie. I have title, I have the year, right? And the table, movie. Yes. So I don't need to go to third table or a second table. I can take all the data from this table. Okay, from this table only. What I want is, I want title and year of release. So I say select title, comma year, select title, comma year from movie, where year is equal to what? 2005 or year equals 2006. Very simple. It's very simple. Okay. I'll write it here for you. I'll write it here. So what I do is that select title, what? Year. Select title and year from which table? From movie table. Okay. Where year is 2005 or year is 2006. Very simple. This will be the query for that. Very simple one. So first what I did is that I find where is the exactly the data will be, and then from that table I extract the data. Second question is, for all movies released in 2005, list movie title and the country of origin. What I want now, I want title and country of origin. So where I get this data, look at movie, I have title. Okay. Do you have country of origin here? I don't have country of origin here. Okay. Where I find the country of origin? I have the country of origin is here in movie country. So how can I relate these movie country along with this use movie? Okay, I should get from table movie and movie country. Okay, how do I relate this both tables? By which key or by which attribute I can relate both the tables, join them. Okay, joining based on what? Based on movie ID. On movie ID. So the my SQL or the query will be, I want title, right? So I say select title, comma, the country of origin. What is the country of origin? Country. Country. Select title, comma, country. From which? From movies join with movie country. Join with movie country on what? On the ID. On movie ID equals movie country dot movie ID. Movie country dot movie ID. So this with this I get all movie IDs along with their country. Movie ID along with their country. But my question here is, which is released in 2005. Then I can add a query like where year equals 2005. Okay. So I'll write it here for you where year equals 2005. That's great. Okay. So I'll write it here for you. This select, what do you want? Title as and the country of origin. From movie join movie country. Is that name movie country? Movie underscore country. Okay, that's great. On what? On movie dot movie ID equals movie country dot movie ID. Okay. Where year equals 2005. This completes my query. Right? Okay. Third query, issue a query to delete all movies released in 1998 or 1999. This should be deleted. This should be deleted. So from where we should delete? We should delete from the movie relation. Say delete from movie. where year is 1998 or year is 1999. Very simple and just one line statement. Delete from movie where year is 1998 or year is equal to 1999. Okay. Simple SQL queries were asked here. So this is how the exam pattern will be for you. Right? So main important is problem solving, which is in part 2 for almost like 90% of the exam is. Okay. No problem. You write a small capital, that's okay, no problem. If you write it capital, that's good. It's more professional. But if you write in a small, that's okay, no problem. It will work. Okay. Any questions? So question 5 from part 1. See, question 5 is about the principle, K, which is Gestalt principle. So I think this is in part 5 or 4. Okay. So go through that. There are some figures given here, there. Okay. So you can look at there. Okay. Fine. The meeting is now record saved. So you can look at this meeting. Let me just take your attendance. Okay then. So let's stop here for today. And next week there will be no